Hey guys, so today we're going to talk about Chapter 10, Section 1, Areas of Parallelograms and Triangles. We're going to be specifically dealing with three equations, that of a rectangle or square, that of a parallelogram, and that of a triangle. So we recall that an area of a rectangle is equal to length times width. Well, in the case of this particular section, instead of calling it width, they're calling it height. Instead of calling it length, they're calling it base. But they mean exactly the same thing. So in this section, they call the area of a rectangle base times height. And they do that for a particular reason. Recall that an area of a rectangle, or a rectangle rather, is a parallelogram, which is a quadrilateral, opposite sides parallel, opposite sides congruent, with four 90-degree angles. And it's because of that 90-degree angle with which they're using length as base and width as height. But it really doesn't matter. You can use length and width or base and height and you'll get the same thing. A rectangle could also be, or a square can also be a special type of rectangle. So if we think about a square, we have our width, we have our length, but in most books they call it S for side, S for side. So an area square is equal to side times side, or side squared. But you can also say length times width. You can also say base times height. They all mean the same thing. So the reason why in this particular textbook they're calling it base times height is because it's a segue into a parallelogram. So we talk about an area of a parallelogram. It is also base times height. Here's our parallelogram. Remember, a parallelogram, opposite sides are parallel, opposite sides are congruent. For something to be considered a height, usually it's a dashed line, and it forms a 90-degree angle with the base. So this would be my base, and this would be my height, because they form a 90-degree angle. And since they form a 90-degree angle, we said there is base times height. And that sort of segues into the rectangle. The rectangle is already 90 degrees. So technically, since it's already 90 degrees, that would be my height, and that would be my base, which is why they use base times height. So you can think of a rectangle as a special case of a parallelogram where the side of a rectangle is already the height of the rectangle, which is what forms the 90-degree angle. When we talk about parallelograms, a parallelogram can have two bases and two heights. The altitude and the height are the same thing. I repeat, the altitude in the case of this and the height, hope I spelled height right, are the same thing. There's really no difference. What they're saying over here is that the altitude is the corresponding segment that's perpendicular to the line containing the base. So these two parallelograms are the same. And if you notice, when the parallelogram is on this side, this altitude forms a 90-degree angle with that base. So this is the height for this base. If we look on the side of the parallelogram, we have this other 90-degree intersection with this guy. So since it forms 90 degrees with this guy on the left, this would be my height and this would be my base. So a parallelogram has 2 bases and 2 heights. So there's a rectangle, and with the square, since they're the same size, the height and the base would be the same thing for both sides. But each parallelogram has 2 heights and 2 bases. Alright, so for the first example that they give us here, example A, we have a parallelogram where we have a height of 4, we have a 5-inch here, we have 4 and 5 inches there. So which one is the base and which one is the height? We have 2 sides to our parallelogram, and we said that the height is always going to form a perpendicular intersection with the base. So since this height is forming a 90-degree angle with 5, the 5 would be our base, 4 would be our height. So we would plug in 5 for base, 4 for height, and we can say that area is 4 times 5, or in this case 20 inches squared. And if we look at B, we have an area of base times height. We have a height here of 3.5. Notice that this height of 3.5 forms an intersection with 2, and it's perpendicular, it's 90 degrees. So 2 is our base, not 4.6, but 2, because this forms a 90 degree with 3.5. And we can say that 2 times 3.5 is 7, and this has an area of 7. So the question for practice problem number 1 is, we have a parallelogram with a base of 12 and a height of 9. What is the area? So area of parallelogram, base times height. In this case, my base is 12. My height is 9, which means that it's going to be 12 times 9, which gives me 90 plus 18, which is 108 meters squared. One thing about area, when you do your units are always squared. And if you're wondering why they're always squared, let's take a look closer to this 12 times 9. Not only are we multiplying 12 times 9, but we're also multiplying meters times meters. So it's 12 meters times 9 meters. 12 meters times 9 meters. So if we rename it, it's going to be 12 times 9 times meter times meter. Well, we already know that 12 times 9 is 108, and we know that meter times meter is meter squared. And that's where the square comes from, just in case you were wondering. Okay. So for number 2, the practice problem that they have, they want to know the distance DE for this parallelogram. So this DE is the height, and it's the height for the base of AB. Why? Because it forms a 90-degree angle with AB. So they give us AB, they don't give us DE. However, we have the 13 inches on the other side, and they give us the height for the other side. So I'm able to probably find DE by first getting the area of the parallelogram, which I can get from FC and AD, which we do in part 1. Area equals base times height, 13 times 9. So my area is 117. Once I get the area, I can use that same equation, area equals base times height, and I can get that 117 equals 9.4 times DE, divide both sides by 9.4, and I can get that DE is equal to 117 divided by 9.4. And we can say that the height of DE is 12.4 inches. So for the practice problem, they say that we have a parallelogram with sides 15 and 18. It says the height corresponding to the 15 is 9, and the height corresponding to 18 is what we have to look for. So we have a base of 15 and we have a height of 9. That's its corresponding height. We also have, for the other side of the parallelogram, a base of 18, and we're trying to find that height. We don't know what it is just yet. So first thing we're going to do is get the area of this particular parallelogram. We know that area is equal to base times height, which is 15 times 9, which is 135. And it's 135 centimeters squared. So that's the first thing, to get the area. The second part is, now that we got the area, we can find the height of the other side of the parallelogram by using the same equation, area equals base times height. But now we have our area, which is 135. We have our other base, which is 18. And now we're trying to find the other height. So we're going to divide both sides by 18. And the other height, which is the one that we're looking for, is 135 divided by 18. And that height is 7.5 centimeters. So, first step, find the area of the parallelogram by doing base times height. The base and times height that they give you, that's corresponding to each other, forming a 90 degree. Once you get that area, then you plug it into another parallelogram equation, substitute that 135 in, substitute the other base, which is 18, divide both sides by 18, and you'll get your other height. So we have a parallelogram. And if I wanted to turn this parallelogram into two triangles, all I have to do is put in a diagonal, right? We can call this triangle 1. We can call this triangle 2. This diagonal cuts these guys into two equal triangles, right? So if we know that an area of a parallelogram is base times height, if I was to cut it in half to form the triangles, then I could say that the area of a triangle would be half of an area of a parallelogram. And that is where the area of a triangle comes from. If the area of a parallelogram is base times height, and I can cut the parallelogram into two equal triangles, basically cutting the parallelogram in half, then I can say that the area of a triangle is 1/2 base times height. And that is exactly where we get the equation from. So our last theorem or equation for this section is that area of a triangle is 1/2 base times height. When thinking about a triangle, it really doesn't matter which side it is. They all could be considered a base. So if I was to draw a dashed line this way, and I know it forms 90 degree, then this would be my base. I'll call it base 1. And this would be my height. I can easily draw a dashed line this way too, which also forms a 90 degree, and I can call this another base 2. And I can call that base 2, and I can draw another 90 degree over here, and I can also call that a base 2. So a triangle has 3 bases depending on which side forms the 90-degree angle. So any side of a triangle could be potentially a base. Parallelograms had 2, rectangles had 2, squares have 2, but they tend to be the same. Triangles have 3. Okay. They give us this triangle here, and they want to know what the area is. Notice that it's a right triangle. So in the case of a right triangle, the side that forms a perpendicular intersection with the base is also the height. So in this case, the height and the side is the same thing. So area of a triangle, 1/2 base times height. In this case, our base is 1. Our height is 5. So 1/2 times 5. We can say that our area is 5/2, or you can say that is 2.5 inches squared. Remember, our units are always squared when dealing with areas. 1/2 base times height. Okay. So the book calls this an irregular figure. I've seen it called complex shapes. I've also seen it called composite figures or composite shapes. And all it really means is that an irregular figure is just comprised of 2 smaller or more smaller shapes that we have to either add or subtract. So in the case of this example here, we have this complex shape or irregular figure or composite shape that says that that is comprised of 2 smaller ones. I see a square. All sides are the same. They're all congruent. All 90-degree angles. And I also see a triangle. So I'm going to add my area of the triangle plus the area of the square. The triangle has a height of 8 because it forms a 90-degree angle. The base is 6 because all 4 sides are the same. So this is 6, then that's 6, then that's 6, then that's 6. So it has a base of 6. So the area of the triangle is 1/2 base times height, which is 1/2 6 times 8, which is 24 inches squared. Then we have the area of the square. Remember we said it's length times width, or base times height, or side times side. They're all the same. So since they're both the same, we say that it's 6 times 6, or 36 inches. And then we just add these guys up together because it's complex, or composite, or irregular. And we get 60 inches squared. For question number 4, they tell us that we have the base of the square and the triangle doubled to 12, but the heights of each polygon remains the same. So what does that look like? Instead of the base being 6, our base is now 12. But they said the height is still the same, so the height will still be the same, so we'll call that 6. We'll call that 6. So this is 6, this is 6, this is 12, this is 12. They said that the height of the triangle is still the same. For 90 degrees, so this is still 8. So this is still 8, that's still 6. We're still doing the same thing. So area of a triangle, 1/2 base times height. In this case, it's going to be 1/2 6 times 12, which is 1/2 of 72. And then 1/2 of 72 is 36. So it's 36 inches squared. Then we have the area of the rectangle. Area of the rectangle is base times height. In this case, it's going to be Oops, this is wrong. Let me fix this. Not 6 times 12. It's 8 times 12. My mistake. So then 8 times 12, I believe, is 96. And 96 divided by 2 is 48 inches squared. My mistake. And then base times height, this is going to be 6 times 12, which is 72 inches squared. So we got the height or the area of the triangle, we have the area of the rectangle, and now we just add them up for our composite or irregular figure. So 48 plus 72 gives me 120 inches squared. So the area of the triangle plus the area of the rectangle is 120 inches squared. Alright guys, this is our 10.1. Hopefully this was beneficial, and I hope you guys have an excellent rest of your day. Stay safe, guys.